So now we're going to do a calculus-based analysis of this problem. Now that we understand the problem and we've done some experimentation and gathered some data, we know that what the velocities are based on our observations, and let's see if the calculus bears that out. So I've shown you the 5-second picture right there. What we want to do is start to define some things, okay? So what we're going to do is we're going to define point A right here as the initial point where we are at the post. Point B is the start of the shadow. That's the front wheel of the skateboard, and then point C is at the tip of the shadow. Okay, the tip of the shadow there. So the two questions that we need to answer are: one, how fast is the shadow lengthening? Well, that question is really asking from B to C. Okay, from B to C. How far is it from B to C? Then we've got, we want to know how fast is the tip of the shadow actually moving. Okay, how fast is the tip of the shadow actually moving? Well, the tip of the shadow would actually be moving at a certain speed, right? And that's, if you think of that point right there, how fast is that point moving? It's moving at a combined speed of whatever A to B is changing by and whatever B to C is changing by, right? Because this right here will move at a velocity equal to the sum of BC's velocity and AB's velocity. Okay, so two questions there to do. Let's look at how we're going to do them. So the first part A, is we want to figure out by what rate is the length of the shadow, the distance from A to B, lengthening. And so that's our goal. So our goal is dl by dt. Oh, by the way, I use this 5-phase process for related rates problem solving. The first phase is to draw your diagrams, label some variables, identify any constants in the question. So that's what I've done here. And you've noticed that I've highlighted the two triangles that are similar. The small one, the pinkish one, and then the yellow one's the larger one. And that's the first phase. So we've already done that. I identified the distance from A to B as x, and the distance from B to C as L, where L is the length of the shadow, and x is how far the skateboarder is from the post along the ground. Okay, that's your lamp post right there. So our goal is dl by dt. How quickly is that shadow from B to C lengthening? What was given in the question was dx by dt. How quickly is this changing, the skateboarder? And we were told it was 3 feet per second. So our goal is dl by dt. So what we typically do with this is we'll start by writing down the given rate. So the given rate is dx by dt. Okay, that's what's given. And then after that, what we want to do is multiply that out and by something so that we can get dl by dt. So I don't have a dl on the top, but I need it, so I'm going to have to write dl. And then I need to, at this point, I've got dl and I've got dt, which is great. But I'm going to need something down here that's going to allow me to get rid of dx. So how do I get rid of dx? I simply write dx down here. So dx by dt multiplied by dl by dx, and that's our chain rule. So that means for me to do that, like this is given, dx by dt is given as 3. Now I need to get an equation that relates L and x. Okay, I need an equation that relates L and x. How are we going to do that? Well, similar triangles just might be our best opportunity. So we know that in the larger similar triangle, this height is 15. In the smaller similar triangle, the corresponding height is 6. So if I was going to do a proportionality statement, I could write that 15 over 6, so if I'm comparing the heights of the two triangles, the larger one and the smaller one, then I could take, that would be x plus h divided by L along the base, right? So that the 15 here corresponds to the full length of the bottom, which is x and L. So that's x plus L. And then the smaller triangle, what corresponds with the 6 is just L right here, right? Just the L. Okay, so, and then, yeah, I could have done that there. There's the smaller triangle. So that's our proportionality statement. Remember, I had to get an equation that related L and X. Well, look at this. I've got L and X. Now, since it's dl by dx, I don't always have to do this, but it's probably a little bit easier if I isolate for L. Okay, I can isolate for L, which I think is not going to be too hard. So let's take a look at how we might do that. So what I'm going to do is simply start with the proportionality statement that we developed. Okay, so we're going to start with that proportionality statement, which is right here, or sorry, right here. Okay, right there. That's our proportionality statement. And then what we've got here is our equation. So we're going to simply expand through, right? So you can think of it as cross multiplying, whatever you want to think of it as. So it's L multiplied by 15, or like multiplying both sides by L, which gives us 15L. And on the other side, we're going to end up with 6 multiplied by X plus L. And so I'm just going to expand that out. 6 times X is 6X. 6 times by L here is 6L. So now we've expanded that out. Remember that I want to get dl by dx, which means I want to isolate for L. So I've just got some simple algebraic work that I do here to do that. I end up with L equals 2/3 of x. Well, my goal is to get dl by dx. So dl by dx, it's a pretty straightforward derivative. That's just linear. So it's simply going to be 2/3, right? The derivative of 2/3 x is 2/3. Okay, so, and I apologize, that was phase 3 where you're developing the derivatives and the rules. So now we go to the fourth phase, which is developing or putting together the chain rule question and substituting in everything that you know and seeing if there's anything missing. If there's anything missing, you figure it out. If not, you solve the problem. So our goal was dl by dt. And that's going to be, we said that was going to be dx by dt, which was given, multiplied by dl by dx. dx by dt was 3 feet per second, and we just got dl by dx as 2/3, and that's meters per meter. Now, what does that actually mean, dl by dx? Okay, it means that the rate of change of L changes by 2 meters every time x changes by 3 meters. Okay, so every time L increases by 2 meters, x will change by 3 meters. Or you can think of it as dl is 2/3 of dx, right? So the rate of change of L is 2/3 of dx. Okay, so what is dl by dt then? And those divide out nicely. dl by dt equals 3 times 2/3 is, that divides out, and it's 2 feet per second. Now, let's take a look at this information that we've got on a diagram now. Back to our diagram. Whoops, there. Okay, there's our diagram. There's A, there's B, and there's C. We know that A to B is, and there's our skateboarder there. This is 3 feet per second, and we're calling that dx by dt. And then B to C worked out to be 2 feet per second, and we're calling that dl by dt. So that answered part A. Part A said, how quickly is the board lengthening? Well, it's lengthening at a rate of 2 feet every second. Or not the board, the shadow is lengthening at a rate of 2 feet every second. This right here is the skateboarder. That's how quickly he or she is traveling. So then the part B question was, how quickly is the tip of the shadow moving? And that, folks, is C. How quickly is C moving away from the post A? Well, again, what would that be? That rate is going to be the sum of those two rates. Because if A to B is lengthening by 3 and B to C is lengthening by 2, altogether it lengthens by 5. So what we would say here is that dx by dt plus dl by dt equals 3 plus 2, which is 5 feet per second. So what I want you to remember is in these questions, there are only, or in these problems, there are only two questions that can be asked, right? Just two questions. The first question is, how quickly is the shadow lengthening? That's the first one, and that's B to C. The other one is, how quickly is point C moving? And when they say that, what they're really meaning, they'll say, how quickly is the tip of the shadow moving? And that's relative to the post, right? It has to be. Okay, so two questions, that's it. And this is almost always, that's the given quantity right there, how quickly, although, you know, you could ask how quickly, how fast the skateboarder is given one of these questions, one of these quantities. Okay, so that's your problem, folks. That's the problem going through it. And again, I think I would solve it the same way every time. Whether it's whether they're asking you for how quickly is the tip of the shadow moving or how quickly is the length of the shadow increasing. Please remember that those are two fundamentally different questions. And with the approach being always figure out what this is usually first, right? How quickly the shadow is lengthening, and then add together your rates to see how quickly C is moving away from that post back here. Okay, hopefully that helped.